friends, hopefully everybody is doing well. Today I wanted to do a quick recap on gas laws and then walk you through the lab. My cat Gritty over here is making a surprise appearance. He doesn't have a lot to say about chemistry, so you're just going to have to listen to me for a second. So here we go. This is a bit of a recap. So last week we talked about gas laws, and I didn't really give you any particular names of those gas laws. So let me present real quick and share my screen. Okay, so the first one I want to talk about is called Boyle's Law. Now this is a good looking fellow named Robert Boyle who came up with the idea of Boyle's Law. He's an English chemist, and he's the one that first said, as pressure decreases, volume increases. And we definitely have seen this because we saw this last week in our marshmallow video. Remember, we put it in this vacuum pump, we sucked out all the air or decreased the pressure, and we saw the volume of the marshmallow increase. Now, for those of you who like to be thorough, we could say this a bunch of different ways. So as pressure decreases, volume increases. The opposite of that is as pressure increases, volume decreases. And not to be outdone, we could do this one more time. Or basically what you should be saying is these two are inverses, or they do the opposite thing. As one increases, the other one decreases. And that's what Boyle said. Our next friend here is, I'm not scrolling very well. This is a good-looking fellow, a French chemist by the name of Jacques Charles, who came up with the idea of Charles' Law. And Charles was a very avid hot air ballooner. And what he first noticed was that as he went up into the atmosphere, up into the air in his hot air balloon, he noticed that his hot air balloon would get smaller. Okay, so think about it. As we go farther away from the ground, the temperature is lower, and therefore we saw that the volume of his hot air balloon was also decreasing. Now, we saw this last week in this video here, where the professor put the balloons in the freezing liquid nitrogen and we saw them get smaller. So we saw as the temperature decreases, the volume decreases, okay? And that's the same thing that Charles saw. He saw as the temperature got colder, the volume of his hot air balloon decreased. Now, afterwards, when they took the balloon out of the liquid nitrogen, we saw as the temperature increased, the volume also increases. And for those of you who like to be really thorough, we could say it the exact opposite way. But basically what is happening here is these two are the same. So they do the same thing, okay? And you get to put these two good-looking gentlemen together and you get what's called the ideal gas law. Okay, and I want to show you something that maybe you want to make on your own. And we put these variables in order. If you notice, P stands for pressure, T stands for temperature, and V stands for volume. And how do I know which order to put them in? I put them in alphabetical order. Okay, so let me show you the benefit of using something like this. Here we go. I'm sorry that this is backwards on your screen, but the first thing I want to show you is Boyle's Law. Now, Boyle says if I keep the temperature constant, if I decrease the volume goes down, the pressure increases. You see how those go the opposite way? Or vice versa. If I increase the volume, the pressure goes down. Okay, so that would be an example of Boyle's Law. Now, Charles said, let's keep the pressure constant. And if the volume and temperature increase, okay, they both increase or they both go up, okay, or vice versa, they both go down, okay? So see how I'm putting my finger on one of these? Now the last one, this ideal gas law, this gives us the last one here. If we keep the volume constant, the pressure and temperature both go up, or the pressure and temperature both go down. Okay, so do you see how your finger is always on the one that you don't really care about? Okay, and then the other ones you can look and see which direction they move. Do they move in the same direction or opposite directions? Okay, so again, like if we think about Boyle's Law, we have pressure and volume. okay? So we don't really care about the temperature. So this is where my finger goes, right? So we can move this like this. When we have Charles' law, we don't really care about the pressure. So we put our finger there and move it this way. This is just another way to help sort of think about it, okay? If you're feeling good, you can go ahead and stop the video now. A bunch of people had questions about the lab from last week. So what I would like to do is spend a few minutes and just walk through the start of the lab for this week. Okay, so again, if you're feeling good, go ahead and stop the video now. If you want some extra help, then keep watching. Here we go. I'm going to share my screen with you again. Ready? Still not interested in chemistry. Okay. Here's me sharing my screen with you. All right. So this is the lab that we're going to take a look at this week. Okay. Here's some vocabulary that you might want to, be interested in, but there's a couple of prior knowledge questions. Okay. So the first one says, why is it often necessary to add air to your car tires before the winter? Okay. So what's happening there? Okay. So what's happening to the temperature? Okay. So I'll keep the pressure the same. And what happens is, as the temperature goes down, what happens to the volume? I hope you said it also goes down. Okay, so in the winter, when the temperature goes down, the volume goes down, which is why we need to add air to our tires in the winter. Okay, conversely, in the summer, the temperature goes up and the volume also goes up, so we don't have that same problem. Okay, let's look at this next question. The next question says, why do you think it might be a bad idea to throw an aerosol can into the fire? Okay, well, let's come back and take a look at this. Okay, so what happens when there's fire? Well, the temperature is going to increase, okay? As the temperature increases, what happens to the volume? It also increases, okay? And if the volume increases, what do you think is going to happen to the can? Well, when the volume increases, it's going to explode, right? So when we increase the temperature, we also increase the volume, and we should find that our aerosol can would explode. All right, sorry for all the back and forth here, but here we go. All right, so now what this is telling us to do is we're going to take a look at the ideal gas law gizmo, which is going to show molecules moving all over the place. See these molecules moving all over the place? Okay, and it's going to say the piston moves up and down and the volume changes. Since gases expand to fill their container, any changes in the volume of the chamber change the volume of the gas within. Okay. Next to the dependent variable, check that the volume is selected. Okay. Volume is selected. Here we go. Using the green slider, change the pressure. Note what happens to the temperature, volume, and amount of gas. Okay. So we're going to use the green slider. As we use the green slider, what happens to the pressure? Hopefully you said that the pressure is increasing, that piston pushed down and it's increasing the pressure on the gas. What happens to the volume? Okay, well the volume is at 22.4. Okay, when we move this, the volume goes to 11.2, so the volume is decreasing. Okay, and what happened to the temperature? Nothing, because again, just like on our yellow card, one of those things is always going to remain the same. Okay. Now, make pressure the dependent variable and use the red slider to change the temperature. Okay, so we're going to make pressure the dependent variable and we're going to change the temperature. Okay, so as I increase the temperature, okay, what happens to the pressure? Let's take a look. So the pressure is at 2. As I increase the temperature, the pressure also increases. What happens to the volume? No surprise, right? Because something always has to stay the same. So when I'm changing my temperature and pressure, I'm not changing my volume. Okay, so now here's what you're going to do. You're going to take a look at this activity, and we're going to make sure we get the gizmo ready. First, select the volume as the dependent variable. Volume, dependent variable. Set the pressure to 1 atm, moles to 1, and temperature to 100. Okay, pressure to 1, moles to 1, and temperature to 100. Okay, so we're basically lowering that temperature. We see nice slow molecules. All right. We're going to be investigating what are some factors that affect the volume of the gas. Okay, so you're going to go ahead and go through this lab. If you need help with this, I will be on Meet this week in order to help walk through what's going on with this lab. So if this wasn't enough, hopefully I will see you on Wednesday and we can talk a little bit more about what this looks like. Okay, so again, I'll put that in the directions. I hope you have a wonderful week, and I miss you guys terribly, and I hope to see you guys soon. Bye.